516. This is Talk the Talk. We're ending our conversation on Lesson 5, which was all about using indirect measurement in order to determine how high or how far away or some things that we just couldn't measure directly, but we can use similar triangles to do that. We're talking Washington Monument in Washington, D.C. If you've never been, go. It's worth the trip. It's the tallest freestanding masonry structure in the world, and it is possible to determine the height of the Washington Monument using only a simple tape measure and a few known facts. For example, this is me that we're talking about. My eyes are 6 feet above the ground. And if I look across the reflection pool, huge, massive, that's located between the Washington Monument and the Lincoln Memorial. That's beginning the setup here. I'm standing between the Washington Monument and the Lincoln Memorial. I'm facing the monument with my back to the Lincoln Memorial, and I'm gazing into the reflection pool, and I notice the top of the Washington Monument. So I'm going to go ahead and just back up so that the top of the Washington Monument is right at the edge of the pool. I've measured the distance from the spot where I'm standing to the spot where I see the top of the Washington Monument in the reflecting pool, and it happens to be green for ground? No, green for height. 12 feet. I'm measuring the distance from my location to the reflecting pool. I also happen to know that that distance from the reflecting pool to the Washington Monument is 1,110 feet. With this information, I forgot one thing. There we go. With this information, I should be able to calculate the height of the Washington Monument. I need to start by drawing a diagram. And you know what? Super important. If you're not doing this step, drawing a diagram, what even are you? Because that's the first step to being successful in these problems. So here's me. Here's my distance to the reflecting pool. I've got 12 feet. I've got 6 feet. So then I'm going to go and extend this to the Washington Monument, which is a giant obelisk made out of bricks. And I have, with the help of a ruler here, the top of the Washington Monument to my eyesight, making similar triangles. Draw the diagram and put the information from the question onto the diagram. Green for green, orange for green for height, orange for ground, which is going to let us create two fractions. So we're going to have an orange fraction and we're going to have a green fraction. And of course they're equal because everything about this is about equivalencies. 6 to the height of the Washington Monument is going to equal 12 feet to the reflection pool and 110 feet, 1,110 feet across the reflection pool from the base of the Washington Monument to where my eyeballs meet. Okay, solve for h, solve for the height. Cross products will do it. So that would be 12h. That's multiplying both sides by h and by 1,110. On the other side, we will have 6 times 1,110. Then I'm going to divide both sides by 12 to give me h equaling this, divide by 12. Hey Siri, what's 6 times 1,110 divided by 12?
6 times 1,110 divided by 12 is 555.
We're saying the height of the Washington Monument is 555 feet. Let's just see how accurate that is. Hey Siri, how tall is the Washington Monument in Washington, D.C.?
The Washington Monument is 555 feet tall.